So in this example, we will create these two parts for the pinball machine, and we are going first, as we started this SolidWorks part mode, we will choose 2 millimeters grams second for a unit. And next thing that we can do, we can choose material. And how to choose material? In our parametric tree, we have all of the informations, and we can right click with the right mouse button on a materials. And as you can see, it says not specified. And I'm going to choose material. In this case, it specifies that this part is made out of plywood. So I'm going to choose the wood. Let's see if I scroll down on the materials. There is a wood. And I can say that this is the, let's say, the beech plywood, doesn't matter. Now, I'm going to start making the parts, and the first part that I will make will be a base for this little toy. It was under the wood here. So, material, right click, and then you go under the edit material or configure material. Pardon, edit material. And then you go all the way down and do any of the woods. So that way it will have a final mass. Now, if I click on a sketch, I will choose to make this actually on the top plane. Let me make this part on the top plane. I will make the rectangle by clicking on the rectangle. I'm going to hover over the coordinate origin, and as you can see, as I hover over the coordinate origin, the cursor gets next to it. It shows that we are doing a rectangle by having a little blue rectangle with the two dots with the corners, and next to it there is a yellow sign with a little sign of a dot with the 3 lines, with the 2 lines crossed, and that means that it will be coincidental. And that means that the point, when I press the left click on the mouse, on the first corner of the rectangle will be coincidental with my coordinate origin. And I'm just arbitrarily going to stretch the rectangle. I can either now, to exit the rectangle drawing command, I can either click here on close dialog, or I can press escape button. Now, this rectangle is anchored into coordinate origin. However, its length has not been determined. The length of the size of it has not been determined. So, to determine the size, I will click on a smart dimension, and I'm going to click with the left mouse button on both vertical lines, and that will give me my distance between 2 lines, and according to my drawings, that distance should be 144 millimeters. And likewise vertical, going to click between those 2 lines, and the vertical distance is 70 millimeters. As you can see, as I have placed those items, those dimensional items, the sketch changed to a fully defined as it is displayed here. So now I have a fully defined sketch. I will click OK to close dialog box. I will close the sketch by clicking on the upper right corner on this green icon. And now you can see that in my parametric tree, I have first created item, which is this sketch. Now, according to the drawing, this is a 4 millimeter stick material, so I'm going to extrude it upward for a 4 millimeters. To create this rectangle into the extruded 3D features, I will click on a features tab, then I will with the left mouse button, then I will click on the extruded boss base, and I will type in a dialog box. It will first say extrude from, and I have an option from sketch plane, surface, vertex, or offset. In this case, we can only use sketch plane because we don't have anything else. Direction will be a blind, what means we will need to specify the distance. And the distance that we are specifying is 4 millimeters, just 4. And we do not have a draft. You can also specify if you want it to be tapered, if you want to have a draft. So 4 millimeters, and then click OK. And look what we got. We got a piece of wood, 4 millimeter thick, sitting there with the right dimension. Now,
You're going really fast. Can you slow down?
sure. So here is my rectangle. Now, to display the dimensions that we know that this object is correct, the easiest way is that we click in a tree on an annotation with a left click, then right click on a folder, and we should have the box checked for show features dimension, as well as with the left hand check the box which shows annotation. Here are our annotations. Now, let's put those two recesses into which we are going to place the goal part itself. So, if we look into those recesses, will be just the two rectangles. However, they are symmetric, so we will see how can we will see now our first placed features. And the first placed features that I will show you will be the same as extrude, however, this time it will be an extrude cut. What means we will cut through the object. You start placed features by placing a sketch. So I click on a sketch tab, again on a sketch icon, choose by left clicking the top surface of this plate, and now I can look straight to it. To look straight to it, I will hover over the view orientation icon, click on a little arrow next to it, and click on this icon which have an arrow, which means look straight to it. Here it is. Now I can draw quite comfortable. Now what I'm going to do, I'm going to make one rectangle here of arbitrary dimension. I'm going to place some dimensions from here to here, and today we will not be concerned about fits and tolerances, so I will just say that this is a thickness of 4, and I will say that this rectangle have a height of 10 millimeters. As you can see, it is still blue. And why it is blue? Because this rectangle is by no way constrained anywhere. So, see, I can move it in any direction I want. Now, if I look at the drawings, it says that left edge of this rectangle and left edge of the part are 70 millimeters distance apart. So I click on a dimension, I click on the left edge of my plate that I just made earlier, and then I click with the left click of the button on the left edge of the rectangle and type in 70. And also, if I look at the right part of that drawing, I can see that the rectangle is 10 millimeter down from the top edge. So I can click on the top edge, and I can click on the top edge of the rectangle, and I can type in 10 millimeters. And close the dimension dialog. And as you can see, this has now turned completely into the fully defined model. Now, I can cut this hole. And how I'm going to cut this hole is I will go on the Features tab, and I will use the Extrude Cut. Last time, remember, I used the Extrude Boss, what means add material. This time I will use the Extrude Cut, which is this frame kind of a shaped icon. So I click on Extrude Cut. It asks me what I want to existing sketch. So I will click on the existing sketch. And instead of blind this time, I will say I want to cut it through all. So I will click on a blind down and I will say through all. And look what has happened. I have created that cut. Now, from the drawing, it is obvious that there is a plane of symmetry in the middle of this part. I can use that plane, and I can use another very useful placed feature, which is called mirror. And now I will come first to the point of the child and parents. Now, this is the first part that I make, the first feature that I made is big plate, and that's the parent. On the top of that parent, I cut the hole, and that hole, I cut that pocket really. I cut that pocket, cut extrude 1, and that's the child of this. Now, a child of this will be a mirrored feature, and I can choose it from this parametric tree that I just want to mirror this around the plane, which will be through midpoint. However, I first need to create that plane. Planes are called reference geometries because they don't exist. They are there just for our references. And how we create the plane? We come here to the right hand, to the menu, to this icon, which is called reference geometry, and click on an arrow at the bottom, and with the left button of the mouse, and then left button, click on plane. Come on, don't block on me. Okay, now I have the plane reference, and plane is always defined by 3 different references, and that can be combination of, like in a geometry, combination of the 3 points, or a line and the point, or 2 planes intersect, or it can be. So first reference, I'm going to choose the midpoint, and if I hover over the midline approximately of that rectangular piece that I created, you will see that it will show me a line with a blue point in the middle, and that means that it picked up the midpoint. I click with the left button of the mouse there, and then you can see it created point 1. Now, I can choose a plane that I want it to be parallel, or I can choose 3 other points. Obviously, faster will be to choose the parallel plane, and the parallel plane will be like this face. So if I click this place, look what it will do. It will automatically fully define the plane, which is parallel with this face and goes through a point which I chose earlier. I click OK. Now I do have my plane defined, that's a midplane. And now I will use the mirror command. Mirror command is the icon called mirror. It's here at the right side of the toolbar. I click with the left mouse click on the mirror. Mirror face plane is the plane that I will use as my mirror. They will choose that plane, and features to mirror I will need to choose in this particular case from the parametric tree. I can't choose it here because if I choose it from here, it will choose entire piece in most instances. So if I click on the little arrow on the side of the part 1, it will open my tree, and I will just choose the cut extrude 1 with the left mouse click, and click OK, and I have completed my part. So, placed features should always be done in a way that minimizes the number of operations, and if I have a 1P feature which is replicated through, we do use commands which just replicate that feature. One of the simplest is a mirror. There are also arrays and a couple of other commands that we will learn as we progress. This is a demonstration just of the workflow. So do the mirror as I just showed you. With this we have completed our first part. In the next part we are going to get introduced to the new placed command, which is the hole command for making the circular cuts. And then we are going finally to make our first assembly, which in the assembly mode, where we will assemble the 2 parts into end products and then make the drawings. And this will give us the full overview of the entire SOLIDWORKS workflow.